Hi, welcome everybody, and thanks for joining us today. I'm your host, Doug Denny, the Director of Technical Marketing for the Dedicated Infrastructure Business Unit at Rackspace, and we are hosting our Deep Dive Hangout today. We host these sessions on the second, third, and fourth Wednesday of every month, and in each session we like to talk about real-world topics geared for practitioners that often involve reference architectures or reports that are derivative of the work we do for our customers here at Rackspace, and give the viewers the opportunity to download and review those assets right here on the page in which you're watching this video. All of the architectures and documents that we talk about can be found at rackspace.com/deepdive, so please do take a moment after the show to browse the previous shows that we've aired, as well as check out the calendar of upcoming shows too. Over the course of the Hangout, if you happen to be watching live, you can use the Google Hangout Q&A feature to submit questions to the panel that we have today, and we'll get to those questions towards the back half of the show. If you're watching on demand via the landing page or YouTube, you can reach us at customercare@rackspace.com with any questions that you might have. And that goes to me and my team, and we'll route those to the right people accordingly and make sure we get your questions taken care of. And with that out of the way, I'll introduce our guests and then give an overview of the topics that we're going to cover today. First things first, let's introduce Robert Ronan. Hi, Robert. What do you do for Rackspace?
How you doing? I'm a product architect with the OpenStack Everywhere team. Been at Rackspace for about 2 years. The first year and a half, I was a solution architect working with customers with private cloud in mid to large size enterprises.
Great. Thanks for taking the time today.
Thank you.
And then we have Walter Bentley. What do you do for Rackspace, Walter?
Yes, Doug, how you doing? Thank you for having me. So I'm just moving into a new role as a senior technical product manager for our private cloud space that's focused on OpenStack. Before that, I was actually a peer to Robert, a cloud architect here in the same organization dealing with OpenStack private clouds. And myself, I am also a 2-year racker. So, my current role, my objective is to be able to create some technical content that can help all those that are looking to consume OpenStack, as well as show off some of the nice things that Rackspace is doing with OpenStack.
Awesome. Thanks for joining us today as well.
Thanks.
And hopefully we'll get to dive into some of that content. But before we get there, I just want to give a quick overview of what we're going to cover today so that folks that are watching can kind of know what to pay attention to. The first is that we're going to do an overview of the OpenStack private cloud offering at Rackspace, and then we're going to talk about OpenStack Everywhere and how that's different or how that extends that concept in new ways. We're going to just have a discussion about the specifics about how OpenStack Everywhere is delivered and deployed. And then we're going to go into OpenStack Everywhere scaling and maximums for that solution. And then finally, we'll have a discussion about how Rackspace extends support and operations into partner facilities like Equinix in support of OpenStack Everywhere. Does that sound good? All right, no objections. All right, so we'll go ahead and dive in. So the first discussion we wanted to have again is what exactly is OpenStack Private Cloud at Rackspace, and what is OpenStack Everywhere? So let's talk a bit about OpenStack Private Cloud at Rackspace first, and give kind of people the background for the conversation we're going to have later in the show.
Absolutely, Doug. So I want to go back a little bit and kind of give some background as to how we kind of ended up where we are right now. So as many of you know, Rackspace was one of the joint partners in creating OpenStack back in 2010. And as things progressed along and as things got turned over to the OpenStack Foundation in 2011, we realized that this is something that many organizations could very well consume and utilize. So we began to create a product around that here at Rackspace that became to be known as the Rackspace Private Cloud powered by OpenStack. And we went through many of the pains and pleasures that everyone else did around OpenStack as far as reference architectures, as far as how to optimize these environments and how to make them scale. And it wasn't really until late of September, around September 2014, where we settled in on what we now consider to be our golden reference architecture around OpenStack. And so hopefully what I'm going to be able to show you up on the screen here is our base reference architecture. So again, it was very late in 2014 where we came to the conclusion that this is a reference architecture that would give you what we would want to call a highly available production-ready OpenStack cloud. And the reason why that's important in this day and age is that you can go through the methods of trying to make it highly available, but it's another thing to make it production-ready. And that's where our reference architecture comes into play, and that's how we're able to solve for that production-ready is by our reference architecture. So if you don't mind, I would like to kind of walk you through this reference architecture a little bit and just highlight the different components that I felt are very important to call out, and then we can kind of take the conversation from there. Is that cool?
Yeah, sounds great.
Excellent. So I like to start at the top when you were looking at the networking and the load balancers and redundant firewalls, right? So the redundant load balancers, redundant firewalls are just good practice, high availability things, right? You never want to have one of anything in your environment. The reason why particularly the redundant load balancers is important is because with our reference architecture, we're using a 3-node control plane, which is pretty standard for OpenStack deployments. But the difference that where we're going after that is that those 3 nodes that are running those OpenStack services are actually in an active format. And what that basically means is that instead of one of the controllers actively receiving API calls and the rest of them kind of hanging out doing nothing, we went about that differently. And what we did is we stood a load balancer in front of those 3 controller nodes, and we're actually going to balance the traffic of those APIs across those 3 servers, right? So that right there kind of helps you be able to scale out your control plane and makes it easy for scaling out your control plane when required. And then kind of going the next layer down, looking at redundant network switches, again, you never want to do one of anything. But the specifics around networking that we did is that instead of leveraging OVS, which is standard practice within the OpenStack community, we decided to go with Linux Bridge. And you may say, well, why would we go against what the OpenStack community prefers? The reason around that is that we found that at the time when we were, because we were kind of at the forefront of building out these private clouds for customers, OVS wasn't holding up to the standards or to the load that customers would put on it when under production, type of loads. It just didn't hold up. And we were having a lot of issues around that. And again, now is a different situation. OVS has grown and matured, and we actually are looking to maybe go back to an OVS backend, but right now we're still using Linux Bridge. And the reason why we chose Linux Bridge is that it's a solid platform. Linux Bridge has been around for years, and it's been proven and trialed and tested against production loads. And by using that Linux Bridge agent, we give you the capability of doing layer 2 and layer 3 networking through Neutron. So layer 2, which is your traditional VLAN trunk to a switch port, you have that capability, as well as you have the capability of doing the whole virtual networking through Neutron, the whole VXLAN type of approach, right? So you get both by us kind of leveraging that Linux Bridge agent instead of OVS.
Okay.
So that's one of the things I like to point out, very distinctly about our differences in our private clouds. The next thing, and then I'll move along quickly because we want to get into the meat and potatoes of OpenStack everywhere, is you'll notice that on the control plane, each of the OpenStack services are kind of in their own little sub area. And the reason for it we depict it that way is that we're actually deploying those OpenStack services in individual containers. Okay. And no, we're not using Docker containers. We're using the original container format, which is LXC, right? So yeah, LXC. So LXC has been around a lot longer. It's been trial and proven to work, as well as we felt comfortable because of the operating system we deploy on, which happens to be Ubuntu. This made perfect sense, right? Because it's LXC is part of the Ubuntu operating system. And by us deploying those OpenStack services in containers, what you gain from that from a capability standpoint is being able to do in-place OpenStack upgrades, right? So as the new OpenStack releases come out, by having these services deployed in containers, you can actually do your Mitaka to Newton upgrade in place without having to stand up new hardware and do side-by-sides. And so that's the reason why we decided to go about it that way, and we found it to be very successful, not just for that, but as well as for scaling out your control plane. If you need more Nova API horsepower, you can actually deploy more Nova containers on a server and not have to deploy the other services alongside with it, right? So it helps you scale very dynamically. And the only other really quick thing I wanted to draw out, because the other standard stuff we're doing around Swift is very standard, straightforward, and the stuff we're doing about compute is very straightforward, leveraging KVM as the hypervisor underneath, and primarily encouraging the use of ephemeral storage on the controller node, I mean the compute nodes. The other thing I just wanted to draw out is that logging server. And this is kind of a spin that we've added to add a little flair to our OpenStack environments. And the reason for that is that anyone who's maintained and operated an OpenStack environment realizes that every one of those OpenStack services has its own log that is on its own directory and kind of separated from everything else. So by deploying a logging server and deploying that Elk stack, we're actually pulling all those logs into one centralized place where we can do centralized analysis and troubleshooting and actually have a visual and be able to do queries against those log information to kind of make sure that your environment is running in the most optimum way and be able to proactively catch problems, right? So we want to catch the problem before it becomes a problem. And by having that logging server, that's kind of giving us a huge leg up of being able to do that nature. So in a nutshell, this is our reference architecture for what we call our Rackspace Private Cloud powered by OpenStack. And these are kind of the under the covers of what has helped us to create that reference architecture to now take it to the next level. And we're going to turn it to Doug and Robert to kind of talk through some of the next level stuff.
Awesome. Thank you. That's good background. And just to be clear, historically, when we were deploying the solution for customers, I know there's some exceptions to the rule, which we're going to talk about, but 9 times out of 10 were these hosted in a Rackspace data center. Is that the way historically this got done?
Well, historically, yes. That's how we really got our feet wet by really hosting a lot of these in our data centers and dealing with multiple customers with multiple different requirements, and this is how we kind of settled on this. One small aside I want to add to that is that lately it's been actually a change in a different direction, and this is where the information that Robert is going to present is going to be very timely.
Yeah, excellent. Okay, thank you for that. So, so then now that we have the background for Rackspace's OpenStack private cloud architecture, let's talk about OpenStack Everywhere and how is that different?
Yeah, sure. So as Walter mentioned, we've been doing OpenStack for a number of years. We've been deploying into Rackspace data centers. We've been deploying into customer data centers based on our reference architecture. About 18 months to 2 years ago, we started to engage with a large financial institution that wanted to take RPC or our reference architecture and effectively move it to the next level. And what that next level was is a full managed service from the floor tile all the way up to the C-suite. So basically, what OpenStack Everywhere is, it's a roll-in rack with a prescriptive bill of materials and hardware based on our reference architecture. All the hardware has been effectively optimized for OpenStack. Everything within the rack is managed top to bottom as part of our managed service, in addition to OpenStack. And then we extend our SLAs into those roll-in racks as well.
Very cool. Very cool. So this means that a customer who presumably wants to consume OpenStack Everywhere, they're not having to procure hardware. There's not a whole bunch of back and forth to determine what device, what type of switch they need and all that. We are providing the end-to-end physical and software and management solution, like basically as a service. Am I getting that right?
Yeah, that's absolutely correct. I mean, I think for a lot of customers that have been, in the data center business, for lack of a better term, or doing their own operations for some time, procuring hardware, compute, switching, the commodity type equipment has become, more of a hindrance or barrier for them to adopt OpenStack or any sort of cloud service within their data center. So we've basically taken that and removed that barrier, made it a single SKU, and now a customer can effectively adopt OpenStack from an OpEx model, both from a software support and hardware perspective.
Okay, yeah, that makes a ton of sense to me. So then, I have a two-part question. Clearly this was born out of an engagement with a large financial services institution. So who is kind of the target audience or market for this, and then why are they looking for a solution like this?
Yeah, sure. So when we built the solution, we definitely had the enterprise or Fortune 500s in mind. That seemed to be our target customer and the customers that were asking most about this. Surprisingly enough, a lot of mid-market or medium-sized businesses have also latched onto this idea as well. When you look at an enterprise, especially anything smaller than Fortune 500, most of those enterprises are constrained for resources, either in the operations team, network teams, or they've got multiple people doing the same multiple jobs. So that's where we see a solution such as this really allowing those businesses to reuse those resources for better purposes. The network guy doesn't have to be the one deploying servers and patching and doing firmware updates. That's all included as part of our managed service.
Yeah, that makes sense. And this is, so personally speaking, this is exciting to me because, one of the things we've long wanted to do here at Rackspace, I've been around for the better part of a decade, is find ways to reach out and deliver, fanatical support to people in different geographies who had constraints that made it hard for them to use our data centers. And we are Rackspace. We don't have the scale of some of the gigantic providers out there, so we're never going to be at a place where we, as Rackspace, have data centers, fivefold in every region of the U.S. and North and South America, right? So this is exciting because we get to bring this to a wider audience. And so with that in mind too, I imagine like things like in our previous discussion we talked about like customers that had like data sovereignty concerns, right? Can take advantage of this. Like, is this open to international customers today or in the future?
It will be open to international customers. We initially, when we launched within North America only.
Sure.
Obviously some countries are a little bit more difficult to do business in than others.
Right.
Due to tax, havens and things like that. So, but if the customer wanted to more or less host this within their data center, or if there's an Equinix data center in that country, it definitely makes things a lot easier.
Sure.
So, the countries that come to mind where we see a solution such as this really being a benefit is, take Germany for instance. They got data sovereignty laws where they can't actually house any sort of data on German citizens outside of outside their borders. It doesn't even extend to the EU. So a solution such as this would be perfect in that scenario where they can adopt both compute and storage in a managed service roll and rack scenario.
Okay, great. And sorry, I didn't mean to get ahead of ourselves. I know this is a fairly new product, but I think it's nice to be able to show where this can go and potentially will go as adoption picks up. So, well, thanks. This is a good introduction to what this thing is. So let's move on to the next topic, which is how are we actually delivering this? Like, what are what is the customer's experience when we engage with them and actually move forward and try to deploy? What are the moving parts? What has to happen? So tell me a bit about deployment.
Yeah, sure. So as I mentioned before, we offer this. This can be deployed in a number of different ways. The easy button here would be to deploy within a Rackspace data center. We've done this hundreds of times already. For our existing RPC customers, and if they wanted to deploy this solution into a Rackspace data center, it's very easy for us to do. We wanted to extend that same ease for a customer into other data centers where we didn't exist. So that's where Equinix came in.
Okay.
So with Equinix, they've built their business on consistency and basically having almost an identical footprint in terms of SLAs, power, cooling, space across the globe. So by partnering with Equinix, it's very easy for us to basically say, it's not going to have any issue running on this, for lack of a better term, floor tile within an Equinix data center. So that's option number 2. Option number 3 is this could be deployed within a customer data center, or if they had another colo of choice, it can also be deployed with there as well. A few advantages with deploying into an Equinix data center, which I didn't mention before, is that Equinix also has something called Cloud Exchange, which is what we're offering as a bolt-on option for OpenStack Everywhere. And what that allows our customers to do is basically integrate or interface into existing public clouds. So for instance, if the customer was an Azure customer or even a Rackspace public cloud customer, they would have the ability to have a full hybrid model based on Equinix's Cloud Exchange technology.
Yeah, I think that's an exciting element to the solution. We had done a deep dive earlier on in the life of the show where we talked about basically Rackspace Rack Connect Global for use cases where we went from a customer premise to Rackspace over a virtual private circuit facilitated by Equinix Cloud Exchange, right? And using an Equinix facility as like a POP, like a point of presence for the customer to sort of terminate their connectivity into from their data center to Equinix, and then writing the back of Cloud Exchange into Rackspace. But that's the whole other side of the equation too, is that Cloud Exchange interfaces with Azure and Amazon, right? And so I think I think that has a lot of value for customers that want to logically extend a data center off premise, but still want it to be governed by their own security policy, or and have that traffic ride over a private circuit, right? If this is sensitive data, or if you have to communicate with systems that run in your current facility that you run, for your business, these are all things that are possible as a result of things like Cloud Exchange. And I can't emphasize that enough. That's a very strong addition to the overall idea of a hosted private cloud.
Right. There's actually a fourth option, which I'd like to bring up too. We've recently seen this with one of our financial customers, is that they were already deployed into an Equinix facility, and due to that, they had the ability to cross-connect into OSE. So definitely, breaking down the barriers and making it easy for customers to, add additional capacity or even a private cloud to their existing, enterprise footprint.
Yeah, that's great. Okay, cool. Well, let's jump into just general sizing, scaling, maximums.
Yeah, sure.
What are the units of consumption for a customer today?
Sure. Let's go ahead and move to the next image if possible. Great. So what you're looking at here is our Rackspace integrated system, or OpenStack Everywhere data sheet. This is going to be a piece of collateral that you can effectively download after the session's over. So we offer OpenStack Everywhere in really two different flavors, and we use flavors as a term here, as a kind of a paying homage to OpenStack. So basically, you've got a small flavor and a large flavor, and the real difference between the two is the amount of scale in which you want to grow into. So our small flavor will scale between 1 and 10 compute racks. Actually, let me correct that statement: 1 to 10 compute or storage racks. It can be any combination of the two. And our large configuration will scale anywhere from 1 to 50 racks. So as a whole, I mean, it's built to scale in both configurations. The small configuration, if you wanted to really, if you wanted to add up the maximum configuration for compute nodes, you're looking at 220 max compute nodes within a small deployment, where large is closer to 1,100. The big difference between the two is the network configuration, or the network cabinet is what we're calling it. The network cabinet within a small configuration is a single cabinet that is built for HA. It's got discrete switching for both our A fabric and B fabric, and has a true HA functionality with VPCs and all those sort of technologies that roll into it as well. The large configuration is slightly different, where we're using a larger catalyst switch, and the reason for that is we wanted to allow our customers room for growth, but we didn't want to count out the smaller customers that wanted to adopt the platform but not take on the expensive going with 9508s for network aggregation. Okay,
and that makes sense. It's one of the core philosophies that we operate in our data center, is this idea of we want to set our customers up to minimize the amount of physical change management they have to endure, over the life cycle of their time with us, right? And I can see the way that sort of manifested itself in the design or reference architectures that we put in someone else's data center, right? We want to. The idea here is that let me know if I'm correct, but it sounds like the idea is we want to set someone up. We want to understand their trajectory early on when we do the first deployment, so that if they scale, if they grow according to the plan, they're going to endure the least amount of physical change management. We're not going to be in there reconfiguring network at several different iterations throughout the arc of their scaling.
Exactly. The entire solution's been architected to be completely modular.
Yeah.
So it scales in a horizontal fashion, just as cloud should.
Yeah.
So as a customer needs more capacity, they're really just adding another cabinet to the configuration versus having to do anything abstract beyond that.
Yeah, that makes sense. And the throughput here is helpful too, because I imagine there's a lot of potential for bandwidth consumption between like block storage and compute in aggregate when you look at a multi-rack deployment. So it's nice to start right out of the gate with a robust architecture for networking, physical networking anyway.
Yeah,
Yes.
and just one this quick thing I just wanted to drop is that the biggest issue that I've seen with deploying clouds and customer sites is all around that networking, and
Okay.
and the fact that we have that kind of slated out, planned out for you to grow is a really big time save, because that's where we spend most of our time when we go to deploy clouds. Sorry, Robert, I have to cut you. I didn't mean to cut you off there.
Yeah, no problem. Yeah, so the entire configuration or solution is plumbed for effectively 20 gigs of aggregate throughput per compute node. So 10 gig is native to the entire stack from top to bottom.
Very cool. Okay, well, let's. I hope we sell a lot of larges. Um, let's jump into the next piece. So we're looking pretty good on time, by the way. We're moving through this content pretty quickly. So um, I think I'll take a break and pause and say, folks, if you're watching live, I want to remind you of two things. One is that you have the ability to ask questions to our panel. So if you have a question, please use the Q&A feature of the Google Hangout to submit those, and we'll make sure we answer those in the back half of the show. And second, again, you're viewing as a viewer these diagrams through a very small window. So I encourage you to actually fill out the form and download the asset to review on your own and study. So with that out of the way, I'll jump back into the discussion. This particular piece is pretty fascinating to me. We're going to talk about how Rackspace extends support in ops in this model. And again, this is interesting because we've built a lot of muscle around supporting and operating infrastructure that under the constraint that it lives in our data center, right? So you guys have found a way to do something new. You found a way to support something that doesn't live in our data center, and I'd like to hear more about how you guys do that.
Yeah, sure. So there's really two pieces to that. There's the process in which it takes to deploy and support, the people aspect, and then there's, how do we technically do it? So let's go technical first. Let's move to the next. There we go. Great. So what you're looking at here, at least in the larger box, where you're looking at customer premise, that also is indicative of Equinix or Colo data center. And what you're looking at within that box is effectively an RPC deployment. So we haven't changed the reference architecture, and that's an important point here to make, is that the reference architecture for RPC or in OpenStack is effectively the same, no matter if it's in OpenStack everywhere or if it sits outside of it. We've made some very minor tweaks, to switching configurations and things like that to optimize the environment. But aside from the reference architecture itself, it's identical to what a customer would find if they just wanted to go ahead and download it for themselves, or if they were an existing RPC customer. There's no real changes there. So how are we monitoring the environment? That's really kind of the core of our managed service. Guaranteeing that uptime of those OpenStack APIs. So we basically deploy what we're calling hubs into our data centers throughout the world. And what those are, these aggregation hubs, is where monitoring traffic is collected, and it's basically all done through DMVPN, or direct multi-protocol VPN. So each site, for instance, in this example, let's use Equinix, would be multi-homed to 2 Rackspace data centers, where we would do data collection for monitoring and things like that. Additionally, all of our out-of-band management and connectivity also comes through that same tunnel. And then any sort of management that needed to be performed on that environment as well would also come through that same tunnel. And that tunnel is effectively, for lack of a better term, air-gapped from the rest of the OpenStack environment, meaning that it's got dedicated discrete interfaces that are not the same as what a customer would be using for instance traffic or anything like that. So we try to keep this heavy demarcation between management and customer interfaces or tenant interfaces.
Got it. Okay, great.
So the second part of that is, how do we do this from a process standpoint? So as everybody knows, Rackspace is a home of fanatical support. What is fanatical support? It is, with regards to OpenStack or RPC, it's a set of processes, runbooks that we develop, and it's an opinionated deployment of OpenStack. So we've taken that and we've basically extended our SLAs and those processes into partner and customer data centers. I guess a good example of this would be, how do we deploy a rack? The process is effectively the same within a Rackspace data center as what you'd find within an Equinix data center. The only difference is that our support services would be remote in that situation versus being localized with operations on the ground. With regards to hardware support and meeting the SLAs around that, there's no changes there. We've also extended our 100% uptime guarantee for networking into Equinix data centers as well.
Okay. Okay. And so if it's in a customer data center, with Equinix, we can rely on a certain amount of uniformity from service from the service that they provide. But in a customer data center, obviously there must be a very clear demarc between Rackspace LAN at the cabinet level and customer network LAN that's managed by their processes and IT staff, upstream into their core routing layer. So is when we sell this to a customer, does the documentation spell out the specific line of demarcation? Is that something that customers can expect us to be very crystal clear about?
Yes, it absolutely does. So, the demarcation is effectively the same, no matter if it's in a customer data center or Equinix data center. The only thing that's really different between the two is that within an Equinix data center, we don't need to do a site survey, meaning that we already know that the Equinix has adequate power and cooling and all the other components that go along with running a data center. Plus, we're extending a lot of our operations to their folks on the ground to do smart hands and things along those lines. With a customer data center, we try to keep the lines just as rigid, and we do need to perform a site survey of the customer site to ensure that obviously their data center can support what we're putting into it, and so that we can basically provide our SLA around it.
Understood. Yeah, I imagine 50 cabinets use a lot of power. Great. Okay.
Yes, it would.
Good. Well, we are doing great on time here. So we've kind of hit all of our key discussions pretty quick, and that's perfectly acceptable that we have come out early. People don't always want to spend the whole hour watching a hangout, so we're looking good. I don't have any questions from live viewers at this time, which is totally okay. But again, I guess if you want to fling any our way, here's your last call warning. So let's do something real quick. So regarding just the OpenStack Everywhere offering, do you guys have a couple sentences you want to make sure stick with the viewers that they remember?
Yeah, so I'll go first. I mean, one of the things that we found with customers that seems to resonate the most is the fact that they have the ability to move to a pure OpEx model. I know this is from an IT standpoint or a technologist standpoint, this doesn't sound too exciting, but when you start really thinking about the efficiencies that go along with that, it's really kind of astounding. I mean, the fact that we can deploy one of these OpenStack Everywhere environments into, let's say, something greenfield in an Equinix data center in 110 days, I mean, to me, that's amazing. Yeah. Whereas I've spoken to customers in the past, and when I was a solution architect on the sales team, and we would start the conversation about requirements, what it's going to take in order to support OpenStack within their customer environment, and then the conversation around hardware requirements, rack space, data center floor space, all those things start bubbling up, and then they start bringing in all these other teams, and it starts getting, it starts becoming a very crowded room, and right. Because of that, time scale and time frames start to extend, and the next thing you know, you're in the next fiscal year,
right.
Looking to deploy OpenStack, and you're basically 2 versions behind.
Yeah, that makes sense. The good news is that we have a solution that will allow you to drastically improve service delivery to your customers. The bad news is it's going to take a year for you to buy it. Yeah, I think that's a very common problem in the business we're in.
There's a lot of moving parts when it comes to basically deploying either a new data center or even a new technology in a data center. And I found this, the larger the company, typically the more difficult it is to do.
Right. And this sort of short circuits a lot of the like discrete procurement and approval problems by packaging it all together, right, in a way that can be consumed as a unit. That makes a ton of sense.
Exactly.
Excellent. Okay, and then regarding delivery and ops, again, we just came out of that conversation, but is there any like one or two bold-faced bullet points you want to make sure that we leave with the viewers of the show?
So again, I'd like to say, OpenStack delivered into a co-location site of your choice within 110 days. That is, kind of like I wouldn't call it the elevator pitch, but that's really kind of the sticking statement that to me makes the most sense. I'll leave it at that. I'll say it in bold.
Awesome. Well, with that, unless you guys have any other things you want to let the viewers know, I think we'll probably dive into closing comments here. So for viewers of the show that are watching on demand, again, if you have questions for the team here, just email customercare@rackspace.com, and we'll make sure we get those questions out to the right folks, so that'd be me, Robert, or Walter, and get those answered for you. Please do check out the other shows that we've aired in the past. We've covered a variety of topics ranging from networking to VMware to dedicated hardware to databases and even Cloud Office, right? So please check out the other content. You should have the ability to share today's show via social media if you found that you really liked it. But also, if you didn't like it, or if we could do something better, just please reach out to us and let us know what we can improve on. And we will issue a post-blog update after a few days, so check the Rackspace blog for the highlights from today's show. Thanks so much for watching, everyone. Thanks, Robert and Walter. Sorry, I really appreciate your time today, and we'll see everybody next week.
Thank you.
Take care, guys.
Bye-bye.